In this video, I'm showing you how to use your TI calculators to solve binomial probability problems. Now, the last couple of days we've been using a formula, and that's still good. There's a built-in function that actually does it much faster. So the first one says find the probability of exactly one number. That you're going to use binomial PDF, and you input the parameters in the order of n, p, x. And basically, vars, which is distributions, and instead of scrolling all the way down, I'm going to hit up once, and then there's the two functions. Binomial PDF for exactly one number, and if you need to find the probability of multiple numbers here, then you would use binomial CDF, and CDF stands for cumulative density function. Okay, so one number will use PDF, multiple numbers will use CDF. And these are questions that involve words like at least, at most, more than, less than, or equal to. With the binomial CDF, the area that the calculator will give you, or the probability, is always including x and the area to the left. So if I could do a quick example, let's say you had a probability distribution table, and the possible values were 0, 1, 2, 3. I'm not going to make up probabilities, but if you were to type in binomial CDF, so there's 3 total. Let's say the probability of success is, 0.3, whatever. And if you were to enter 2, the answer that it's going to give you is basically including 2 in all the area to the left. And again, that's something that we'll practice more with. So I'm going to work through this problem using your calculator. Studies show that 70% of the families in Pinellas Park, both the husband and the wife work. If 7 families are randomly selected, what is the probability that, and then we'll answer some questions. Now, the first thing we want to do is identify the parameters of the binomial distribution. N is 7. That's the total number of families selected. And then we have P, which is the probability of success, which in this case is 0.70. Okay, now, instead of using the formula, we're looking for the probability that exactly 4 of them work. So that's basically x equals 4. So I'm going to use binomial PDF for exactly, now in the order that I type them in again is n, 7 out of 7, probability of success is 0.0, I want the probability of getting exactly 4. So I'm just going to type that right in my calculator. Binomial PDF 7, 0.7, 4. Hit enter and voila, 0.2269. And this is the part where you all get mad at me because I didn't show you this right off the bat. Because I want you to understand what those numbers mean. Now, these number 2 and 3 get a little trickier. It says less than 4 work. Now, what I'm going to do is I'm going to make a dummy table. And a dummy table is a probability distribution table that isn't the full table. So I'm going to do something like this. 4, 5, 6, 3, 2. Dot, 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 dot. These are basically the possible values of x. If I were to make, let's say, this table down here at the bottom. I'm not actually going to make it, but it'll help me visualize. So it says less than 4 work. Less than 4 does not include 4. It's 3 or less. So it's a multiple probability problem. So I'm going to use binomial CDF, C for cumulative, means more than one number, and out of 7, probability is 0.70. That's all pretty much the same. But now in this case, I want the area of 3 and less. So I'm actually going to enter a 3 in here, not a 4 that was in the original problem. And again, this little dummy table can help me figure that out. So second vars, I'm going to go find binomial CDF. And I'm going to enter 7, 0.7, 3. and I will get 0.126036. Let's call that 0.1260. 0.1260. So basically what that does is that adds up the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. And if I were to do those individually, 4 separate problems, I'd get the same answer. Okay, so this is a much faster way of doing that. Now, next problem says more than 4 work. So again, I'm going to do my little dummy table, 2, 3, 4, 5, 6, just so I can visualize what's going on if I were to use my probability distribution table. Now it says more than 4. More than 4 does not include 4. It's 5 or more, basically. So I'm going to use, now I have to kind of indirectly find this. I can't get the area to the right because the function in my calculator only gets the area to the left. So in this case, the only thing that what's not included in my kind of shaded area is 4 or less. I can get that probability by typing that into binomial CDF 7.74. That's basically going to get me all of this area, which is not what I want. I want the other side of that, so I'm just going to subtract that from 1. I type that again right in my calculator. 1 minus second bars binomial CDF 7, 0.7, 4. And I'm going to get a final answer of 0.7731. Now, some people don't like to do it that way. They don't like to type in it all at once. So what you can do is you can do binomial. You can basically write it down. Binomial CDF 7, 0.7, 4, 0.3529, and then subtract that from 1, 0.3529. So you can do 1 minus 0.3529, and you'll get that same 7731. And again, that's the equivalent of taking the probability of 5 plus the probability of 6 plus the probability of 7 individually, but this calculator function allows me to do it much faster. Okay, now for the easy part, the mean. NP, so out of 7, I expect 70%, which is 70 times 0.7. So, no, 7 times 0.7, 4.9. I expect out of 7, about 4.9 families to have both the husband and the wife working. Standard deviation is the square root of NP 1 minus P, so that's the square root of 7 times 0.7 times 0.3. And that's going to give me 7 times 0.7 times 0.3 and 1.21. 1.21.